In this video, we'll be covering Part 3 and Part 4 of the June 2022 Geometry Regents exam. First up for Part 3, these questions are 4 points apiece and you can earn partial credit on them. All right, 32 is modeled below a projector mounted on a ceiling 3.74 meters from a wall where a whiteboard is displayed. The vertical distance from the ceiling to the top of the whiteboard is 0.41 meters, and the height of the whiteboard is 1.17 meters. Determine and state the projection angle theta to the nearest tenth of a degree. Okay, so if we take a look at this, this is what I like to call a double trig problem because I can kind of see that I'm going to be using SOHCAHTOA here, but there's really two triangles that I need to use, hence the double trig. And if you look at the triangle that theta is in, this is not a right triangle, so I can't just use SOHCAHTOA. I've got to find another way to basically figure out what theta is. So what I'm going to do is I'm going to separate the two triangles. And I'm just going to draw them separately here. So here's the small one from the top. This is 3.74. This is 0.41. And let's call that angle here x. Okay. Now let's draw the big right triangle. This is 3.74 again. Over on the right-hand side, we have to add 1.17 plus 0.41, and we get 1.58. And let's call that angle y. So if you look at how I've labeled it on the initial picture, we should agree that if I take y and subtract angle x from it, I'll be left with theta. And that's going to be our game plan in solving this problem. Now let's look at each of the two pictures. In this first one here, I'm going to be using tangent, and really most double trig problems are tangent problems because I have the opposite side and I have the adjacent. So the tan of x is equal to 0.41 opposite over the adjacent. When I am solving this, this is what it should look like. I'm doing inverse tangent. Anytime you're finding an angle, you're doing the inverse or opposite operation. And I'm going to put that in my calculator. So second button and then tangent to get that. And then I have 0.41 divided by 3.74. And this is not my final answer, so I am not going to round anything. I'm just going to copy all of these numbers from my calculator screen. All right, let's basically do the same exact work over on the second triangle here, except we're using y. And the length of the opposite side has now changed to 1.58. So I'm going to once again use inverse tangent and put that in my calculator. And y is 22.902.107.8843. So before we said that theta is equal to y minus x, so let's subtract that answer. So we're going to take 22.902 and so on, subtract the 6.25, 6106, 424 from that. And we are going to now take this answer and we are going to round to the nearest tenth. So if I take my answer here, round to the nearest tenth, I get 16.6 degrees. All right, number 33 is a proof. We are given a few things that we have a parallelogram and some perpendicular lines, and we need to figure out how to prove that P of T and RU are congruent. So let's start off by making our statement reason table. And I'm going to go right in and I'm going to start filling in all of the statements for the givens. So parallelogram PQRS, we know that QT and PS are perpendicular, SU and QR are perpendicular, and our reason is given. All right, well, let's think about what we can elaborate upon there. So in our end goal here is to prove that PT and RU are congruent to one another. We can see that those are part of the triangles RUS and PTQ. So we really need to figure out a way to find these triangles are congruent to one another. So let's look at the first given. The first given tells us that we have a parallelogram. And let's think about some properties of a parallelogram that could help us. So for instance, one I can think of is that angle R has to be congruent to angle P because opposite angles in a parallelogram are congruent. Once I've said that, I'm going to mark those two angles off in my picture. I am also going to add in that RS is congruent to PQ because opposite sides in a parallelogram are congruent. And we're going to mark those off. So using that first given about a parallelogram, I was able to mark off two pieces in this. And now let's look at the other given. We are given that we have two sets of perpendicular lines. Perpendicular lines form right angles. And you can see here that there's a right angle in each of those triangles. So let's talk about those in our proof. So for line 4, I'm going to say that angle RUS and angle PTQ are right angles. My reason is that perpendicular lines form right angles. And then I need to also say that those two right angles are congruent to each other. And they're congruent because all right angles are congruent. All right angles have a measure of 90 degrees, so therefore they're congruent to one another. So once I finish line 5 here, I have enough information to prove that the two triangles are congruent to each other. So for 6, I'm going to say that triangle RUS is congruent to triangle PTQ, and that's because angle side is congruent to angle side, basically the angle side congruence theorem. And then our proof statement must come last, so PT is congruent to RU, and that's by CP/CTC, because those are two corresponding parts of congruent triangles, therefore they must be congruent to each other. Okay, for number 34, we have kind of more like a real-world application question. These are common on the part 4 or part 3 and part 4 questions. All right, a concrete footing is a cylinder that is placed in the ground to support a building structure. The cylinder is 4 feet tall and 12 inches in diameter. A contractor is installing 10 footings. Right off the bat, I notice the mismatch of units. This is very common for the Regents to do on any volume question. So I'm going to get them to match. I'm going to change that 12 inches to 1 foot. If you're saying to yourself, well, how do I know which one to change? Do I change 4 feet to inches, or do I change the 12 inches to feet? I would just glance down at the rest of the problem. I can see here it says if a bag of concrete mix makes 2/3 of a cubic foot of concrete. So I can see an indication that I want my units to be in feet, and that's why I changed the 12 inches to 1 foot. All right, we're going to basically figure out how many bags of concrete are needed to make the footings. First, let's start with the volume. Volume formulas can be found on your reference sheet. So volume of a cylinder is pi r squared h. The radius is going to be 0.5 since the diameter is 1. And our height is 4. And we are going to actually, I'll multiply this right by 10 here because we have 10 footings. So I'm going to put this in my calculator. Pi times 0.5 squared times 4 and then times 10. So the volume of all 10 footings is 31.415,926,5359 cubic feet. It says if a bag of concrete mix makes 2/3 of a cubic foot of concrete, determine and state the number of bags of concrete needed to make all 10 footings. So we have a couple of ways that we could go about writing this. I see I need to convert somehow. I need to figure out how many bags is equivalent to this amount of cubic feet. So what I like to do is I like to take the unit that I'm going to convert and put it over 1. And then make a fraction next to it that basically represents the other fact that I know. So I know that 1 bag is going to give me 2/3 cubic feet. The reason this works is the cubic feet will cancel out, basically be eliminated, and I'll just be left with how many bags I need. So I need to basically divide my answer by 2/3. Carefully type that into your calculator, by the way. And we want the minimum number of bags. So 47.123, I can't go to the store and buy 47.123 bags. I'm going to need to buy 48 bags in order to have enough. If I have to round up, 47 would not be enough concrete. All right, for our last question, part 4, this is a 6-point question. And again, there's partial credit all throughout. All right, let's start off. It says the coordinates of the vertices of triangle ABC are given to us, and we want to prove that ABC is isosceles. Then we are given some information down here about a translation, and on the back we want to prove it's a rhombus. So let's note that for both of these parts here, it says that use of the axes below is optional. Anytime you see that, I personally would recommend graphing it. I do think that that makes the problem a little bit easier, just visualize what's going on. So I'm going to go to my graph here and I'm going to plot the 3 points they gave us. So they tell us that A is -2, 4, that B is -7, -1, and C is -3, -3. So I'm going to plot those, use straight lines to connect them. Always label your points too when you plot a -2, 4, for instance. Make sure you put the A next to it. All right, so the first thing we're asked is to prove it's an isosceles triangle. So an isosceles triangle is one that has 2 congruent sides. Here's where I like the picture. It looks like AB and AC are going to be the congruent sides. So my work should basically match that. All right, so I'm going to scroll back up over here. If I want to find the length of each side, I'm going to use the distance formula. That's where I'm going to subtract the x's, square it, subtract the y's, square it, and I got radical 50 for the length of AB. It doesn't matter what order you subtract the x's in, by the way. When you square it, you'll get the same answer. All right, let's find the length of BC. When I subtract the x's, I get 4. When I subtract the y's, I get 2. And that gives me radical 20. And then let's see what happens with CA. Subtract the x's, I have 1. Subtract the y's, I have 7. And I get radical 50. Those are my 2 congruent sides that I identified from the picture that look like they were congruent. So I'm going to just write a sentence here concluding. I'm going to say, since triangle ABC has 2 sides of the same length, it is an isosceles triangle. So basically, our sentence at the end is just recapping what work we have shown so far. All right, the next part, state the coordinates of triangle A prime, B prime, C prime, the image of triangle ABC after a translation 5 to the right and 5 down. Okay, so A was -2, 4. That basically means I'm doing a translation 5, -5. So I'm going to add 5 to the x coordinate and I'm going to subtract 5 from the y coordinate, giving me 3, -1. I'm going to repeat that same process for b and c. B prime is going to become -2, -6. And c prime is going to become 2, -8. If you wanted to do this question graphically, by the way, you can certainly look at the picture that we had before and just count the boxes to move each box or each point 5 to the right and 5 down. All right, on to the last part of this question and of the whole exam. It asks to prove that A prime, C is a rhombus. So what I'm going to do is I'm going to write down what all of these coordinates are just to keep everything straight here. So A is -2, 4. A prime is 3, -1. That's what we just found. C prime we just found is 2, -8. And C we were given to us is -3, -3. Okay. So in order for a quadrilateral to be a rhombus, all 4 sides have to be congruent to one another. We already know that AC is radical 50 because we found that in the first part of the problem, so it's not necessary to repeat that. So let's find the others. So let's do, we'll do A prime. And I'm going to subtract the x's, subtract the y's, and I do get radical 50. Okay, the next side would be A prime, C prime. When I do that and subtract the y's, I get 1. Excuse me, the x's I get 1, subtract the y's, I get 7, giving me radical 50 again. And then I have C prime C. Subtract the x values, I have 5. Subtract the y values, also 5. So radical 50. All 4 sides came out to be the same length, so therefore this is a rhombus. So I'm just going to write that. I'm going to say, since all 4 sides have the same length, A prime, C is a rhombus. Always make sure you have your sentence concluding there, basically just explaining whatever work you showed and why you did it. Okay. All right, everyone, make sure you check out the rest of my channel to see other videos going over past Geometry Regents exams.